Transistor is one of the very important devices in electronics. Let me explain about this transistor and its various configurations. A transistor can be represented by this symbol. This is the base and this is emitter and this is collector, emitter. First of all, you should be able to identify the type of transistor, whether it is PNP transistor or NPN transistor, based on the circuit diagram. Here, when the charge carrier of the semiconductor, particularly the transistor, is negative, then negative means electrons. You know, the direction of current is opposite to the direction of electrons. Suppose if the negative charge carriers are emitted towards the base, that is E to B, then the current should be indicated in the reverse direction. So you can easily identify the type of transistor, whether it is a NPN or PNP. Now this is NPN. Let me consider PNP. This is the base. This one is the collector and this is emitter. Here the majority of the charge carrier is positive hole, that is PNP. So here positive holes are the charge carriers, and in fact the direction of current is in the direction of positive holes. So in that case, the positive charge carriers are emitted by the emitter towards the base. So the direction of current is also in the same direction, from E to B. So when the arrow mark is towards the base, you can immediately say this is PNP. The arrow mark is away from the base, then you can say it is NPN. So this is a simple way you can identify the type of transistor. The configuration of the transistor here, it is, in fact, this is the input and this is the output. So in between you have the emitter, so this must be common emitter configuration. And what about this? This is also common emitter configuration of PNP type. This is common emitter configuration of NPN type. So similarly, we can arrive at the common base also. Now let us draw this diagram. Let us attempt now common base, that is NPN, common base NPN. As I have already explained, you can simply represent by a round, and this is the base. Now emitter on the left side, collector on the right side. So emitter, as you know, this is NPN, so the direction of current is away from the base. Okay, it means the negative charge carriers are emitted towards the base. this is the collector. So this is NPN common base configuration. Okay, and what about common base PNP, common base PNP? Now let us put the common base here, and emitter, collector. Now this must be pointed, the arrow mark should be pointed towards the base, and this is emitter, this is collector. Now this is very simple. We are now discuss 1, 2, 3, 4 types of configurations. Let us proceed with common collector, but it is not efficient, and that is why we can consider these two. Among these, a common emitter mode and common base mode. Common emitter has more advantages. Okay, right. Now what we are going to do is we are going to further build up. Okay, now you can look at this circuit diagram. This is the common base mode. Now can you identify the type of transistor, whether it is a PNP or NPN? You know very well, this is away from the base, so this must be NPN. And what about this one? This is also NPN. What about this one? This is also NPN. So this is NPN of 3 modes of transistor circuits: common base mode, common emitter mode, common collector mode. Or you will follow? So here we have the common base, common emitter, common collector. As I already explained, the common collector has the poor efficiency. We can ignore that. Now let us consider these two, common base mode and common emitter mode. Now both of them are of NPN type. If we want to convert this into PNP type, then you have to change the direction of current. For example, here instead of the arrow mark showing outward the base, you can convert towards the base. Okay, so that becomes immediately, that is PNP, positive charge carrier, and accordingly it will change the polarity also. You have to change the poles. For example, here this is NPN, so majority of charge carriers are negative. Here forward bias takes place at that is in the input voltage here at emitter. For instance, here you have got the charge carrier negative, so the negative is pushed towards the base, so this is the forward bias, and here it is the reverse bias at the collector junction here. Are you able to understand? So that is why we have put the positive charge here, so that we can have the reverse bias, and this is the base. So this is a simple representation of transistor with common base mode. Similarly, common emitter mode can be represented here. In this case, now this is the common emitter. In the base, it should have positive, so that is because the electrons should be pushed towards the base, so that it can be positive. And here the electrons are pushed inside, that is forward biased here, and the collector is reverse biased here by attaching to the positive potential. Okay, positive pole at the output. And here the common collector, in the common collector we used to have, for instance, on one side it is a minus, on the other side it is plus, and that is why its efficiency is weakened here. So we don't consider the common collector mode as an efficient one. We take only these two, right?